In this example, we'll look at how to calculate coordinates to draw a bar graph showing the growth of an investment over 10 years in which the values are no more than $10,000. The figure here from the textbook shows the layout of the window, and we will look at how to calculate the values it shows. The window will be 320 by 240 pixels, and the bars will start 10 pixels from the bottom. So $0 will be at y equals 230. We'll leave a border of 30 at the top, so we have 200 pixels in height to represent $10,000. We can then calculate that there are 0.02 pixels per dollar. We want labels every $2,500, so similar to the way we calculated unit conversions, we can determine that each label will be 50 pixels above the previous label. Since $0 is at y equals 230, the y value for a given dollar amount is 230 minus 0.02 times the dollar amount. Note the dollar units cancel, leaving us a result in pixels, which is what we want. We will leave 40 pixels at the left edge for the dollar labels. This means that the x-coordinate for the left edge of the first rectangle will be at x equals 40. We want 11 rectangles since there is one for the initial amount, and then 10 rectangles for the amount each year. We will leave a 5 pixel border at the right edge. This means we have 320 pixels, minus 40 pixels on the left, minus 5 pixels on the right, equals 275 pixels for the rectangles. Dividing that by the number of rectangles, and each rectangle will be 25 pixels wide. So that we can write the code in a loop, we need a formula in terms of the number of years to indicate the left x-coordinate for each rectangle. Since each rectangle is 25 pixels wide, we need to move over 25 pixels each time. So we multiply by 25. And since we want year 0 to be at x equals 40, the formula is year times 25 plus 40. Note this works as year 0 will be at x equals 40, and year 1 will be at x equals 65. After doing these calculations, we are ready to start writing the program in PyCharm. This program from the book uses a main function. Recall that the code indented under def main is the body of the function, and we need to call the main function for the code to execute. We are using the graphics module, so we import it as we have been doing. This program allows the user to enter the initial amount and the interest rate. We create the 320 by 240 window and set the background color of the window to be white. Next, we make text objects for the labels on the left-hand side. Recall from our calculations that 0 is at 230 and every $2,500 was 50 pixels. So each label is 50 pixels above the previous label. In most cases, we assign a variable to the objects we create, such as we did below with the rectangle. This allows us to then call the other methods to set the color and the border width of the rectangle before drawing it. In this case, we do not need to do anything else with the text objects, so instead of saving them in a variable, we immediately take the result from the constructor and call the draw method. Once we draw it, the graphics window keeps it on the screen, so we don't need to store each text object in a variable. After creating each label, we create a rectangle for the initial investment amount. As we determined in our calculations, every dollar is 0.02 pixels, so the height of the rectangle is 0.02 times the initial amount. The bottom left corner should be at 40, 230, and then since the rectangles are 25 pixels wide, the upper right corner is at x equals 65 and y equals 230 minus the height. After making it green with a 2 pixel border, we draw it. Now we're ready to use a loop to apply interest and update the amount each year, as we've done in previous interest calculations. Note that we used range of 1, 11, so the values of year will go from 1 to 10. We can then determine the coordinates for the rectangle used in the calculations as we did earlier. The lower left x-coordinate is the year times 25 plus 40, since each rectangle is 25 pixels wide, and year 0 is at x equals 40. The first time through the loop, the year will be 1, so the left x-coordinate will be 65, which is what it should be. We can then calculate the height as we did before using the updated principal value. Now we're ready to create the rectangle with the lower left coordinate and the upper right coordinate. Note by adding 25 to the x-coordinate, it will be 25 pixels wide. We can then set the fill color and border with as we did before and draw it. We'll debug it and watch the first few iterations of the loop to see how the values change. We'll enter $1,000 and 10%. With the breakpoint on the bar.draw line, we'll stop just before we draw each bar. We can see the values of year, XLL, principal, and height. We can press the resume option to execute the next iteration of the loop, stopping just before we draw the next bar. Now year is 2, and we can see the updated values for the year, XLL, principal, and height. I'll remove the breakpoint now and press the resume option so we can see it continue executing and drawing all the rectangles. Now the program is at the win.getMouseLine, so I'll click the mouse in the window and the window will close, and the program finishes.